Alright guys, this is the boring bit, but I gotta teach you the terminology for what's happening inside of an electric cell. We have two beakers with solutions inside each of them. We have metal plates submerged in each of the solutions, and these metal plates are called electrodes. The two electrodes are connected with a wire, and there's a little tube of gel stretching from one beaker to another. Usually the beakers are close together, and this is just a U-shaped U. Inside is a gelatin with salt in it. And when I say salt, it's almost always potassium nitrate. This is called a salt bridge, and what it does is it helps to counteract any changes in charge that will be happening. As you know, these reactions have electrons flowing from one side to another. You're losing minuses and gaining pluses in all these different places. This salt bridge helps keep everything overall in each area neutral. So, what's actually happening in each beaker? Well, the way that I've set this up, I've got copper 2 becoming copper. That copper 2 is gaining electrons. So this side represents a reduction. Reduction is a gain of electrons. This iron is becoming iron 2 plus. Well, where are the other two electrons going? Well, they're gone. That iron lost the two electrons, was left with a positive charge, and those electrons are now just somewhere else. Oxidation is our word for the loss of electrons. And based on which is happening in which beaker, reduction and oxidation, we have special names for each electrode. The beaker/electrode where oxidation is happening is called the anode, and the electrode where reduction is happening is called the cathode. This is often referred to as the negative electrode, and this is often referred to as the positive electrode. When you have a AA battery or a D cell battery, and one says plus and one says minus, the negative side is the side where the electrons are coming out of because it's losing electrons. And you're pumping the electrons through your device back into the other side, the plus side, because that's the side that needs to gain the electrons. Now, based off of this, we have a primary cell. Primary cell. A primary cell is a setup just like this if it cannot be recharged. If it can be recharged, it gets the name secondary cell. The best analogy I have there is that those AA batteries are often primary cells, but the rechargeable ones are secondary cells. Pretty straightforward. The last point that I need you to recognize is that if this side is losing its electrons, and this side is gaining electrons, that means through the wire, the electrons have to be traveling this way, where every time an iron dissolves into solution to make an iron 2 plus, we generate two electrons and they have to go somewhere. They go through the wire to here, because every time two electrons arrive here, we're able to reduce a Cu2 plus ion into a solid copper ion. One last thing I'd like to point out is that because this is solid iron becoming iron 2 plus, this electrode is slowly going to deteriorate away. Pieces of it will start falling off because, after all, it's made of solid iron and it's becoming Fe2 plus ions in solution. It will disappear until, well, there's nothing left. Here we have copper 2 ions in solution, and they're going to be reduced to solid copper. This electrode will slowly grow and grow and grow and grow and collect a layer upon layer of solid copper on top. Key points you need to remember: oxidation happens at the anode, reduction happens at the cathode. You always need two electrodes, in your solutions. Your electrons travel from anode to cathode, i.e. negative to positive, and you can always predict which is the anode and cathode based on the chemical reaction that you're forcing to happen in these cells. Hey, best of luck.